And now we move to the relationship between linear and circular convolution. So to investigate the relationship between these two types of convolution, first we do a typical linear convolution for n-point finite sequences yn between the first signal x1m with x2m modulo n equal to 4. And then the second step, we shift endpoint to produce yn plus n. We choose n like this, equal to 4 or equal to 7, and we determine the value of this shifted value of yn. And the third step is to add both results for yn and yn plus n. We add these two results to produce these results of circular convolution between these two signals. Okay, and now we check for this example the convolution between x1m and x2m using a linear convolution that produce yn. This is the result yn. This is step number 1. And then step number 2, let's say we choose n equal to 4 to produce yn plus 4. So we shift this signal to the left by 4. So this one move here. Okay, 1, 2, 3, 4. So we have this result that has been shifted by 4 to the left. The rest is 0 based on this one. And then the third one, we add both result yn. We add with yn plus 4. So we add this one to produce circular convolution x1n with x2n. This is a symbol for circular convolution. In this one, n is equal to 4. So this is how we write x1n based on the circular convolution for n equal to 4 with x2n. So we add these two to produce this result. So we add this, we have 3, 1, 3, 5. This one for only n equal to 4. So this is for n equal to 4 from n0 until 3. The rest is no signal. Okay, not 0 but no signal. Okay, if we check this one, and for this one the value of signal is 4. The length L is the length for x1 signal. The value is 4. And P is the length for x2 signal. The value is 4 points of signal. And then for time aliasing in circular convolution of two finite sequences with length L and P can be avoided if and only if n is equal or larger than L plus P minus 1. So we calculate L plus P minus 1 is equal to 7, and we try for n equal to 7 in this case. Let's say we try n equal to 7, and in this case this is again the same results from typical linear convolution for yn based on this value, a convolution between x1m and x2m. So this is the result. And the second step is we shift endpoint. We choose n equal to 7 based on this calculation. And for this one, if we shift this signal to the left by 7, we have 0. Okay, we have 0 all the way. And we add these two signals for steps 3 to produce circular convolution between these two signals. Okay, when we add these two, we have this result. Okay, so this is the circular convolution between x1 and x2 for n equal to 7. These two signals, we analyze that at this point, aliasing occurs because yn is not equal to this result of circular convolution for n equal to 4. At n equal to 0, yn is equal to 0. At n equal to 0, the circular convolution results is equal to 3 based on this shifted value. Okay, and therefore aliasing occurs. Okay, so this is the 4-point signal of circular convolution, the results of 4-point circular convolution 3 1 3 5 3 1 3 5. And when we sketch for the 4 points DFS, so this is for 0 until 3, the 4 sets of the original result, and we repeat on the left and right side, we found that aliasing occurs between -1 and 0, between 3 and 4. Okay, at the beginning of the sets of 4-point signal, because of this one, yn is not equal to the circular convolution results for n equal to 4, so aliasing occurs. But since we choose this n equal to 7, so that the time aliasing in circular convolution can be avoided, so we choose n equal to 7. So these results, there's no aliasing occurs since yn is equal to the circular convolution between x1 and x2 for n equal to 7. Okay, it has the same results for yn and also the circular convolution. It produced the same result, so no aliasing occurs. So we have a space in between this one, and no aliasing occurs as this one. Therefore, time aliasing in circular convolution can be avoided if we choose based on this one. We choose the value of n, okay, for the circular convolution point based on this one, where n is equal or larger than L is the length of the first signal, plus P is the length of the second signal minus 1. So for further reading, please refer to the monograph based on this chapter, properties of DFT, DFT convolution for linear, DFT convolution for circular, and the last one is the relationship between linear and circular convolution. With that, thank you very much.